Gentlemen, in 10.5, we examine angles related to a circle. There are 4 objectives. Determine the measure of central angles, the measures of inscribed and tangent chord angles, the measures of chord angles, the measures of secant, secant-tangent, and tangent-tangent angles. Now that's a lot of words. So let's focus back on the purpose of geometry. We want to move away from the external reasoning, which is some other source tells me, the teacher, the textbook, something else outside of me tells me, into analytic reasoning, which is where I make an inference, or you make an inference, seeing patterns, recognizing the patterns, and then forming your own generalization. So all of those objectives are summarized in your textbook in this chart. I'm going to ask you to focus on this for a minute and see if you can come up with your own generalization. Please pause here. So my generalization is if the vertex of an angle is the center of a circle, then the measure of the angle is equal to the arc. If the vertex of the angle is inside the circle, not the center, then the angle is equal to the sum of the arcs divided by 2. And a mnemonic to remember that is if something's in, if it's in fashion, in bounds, that's a good thing, right? So in, it's a plus. If something's on the circle, if the vertex is on the circle, we learned in 9.2 that the angle is equal to the arc divided by 2. And then if something is out, like baseball, you're out of here. If it's out, that's a bad thing, so that's a negative. So the measure of the angle is equal to the arc minus the arc divided by 2. In 9.2, as well as 10.3, we learned that the measure of the central angle is equal to the arc that it forms. So if this is the measure of the angle that we're looking for, we know that that angle is equal to that arc. So the measure of the angle is equal to 120 degrees. Now try the one next to it. Algebraically, we would set those two equal to each other because that's a central angle and it's equal to the arc that it forms. So 6r plus 7, I have to zoom in there, is equal to 7r minus 13. And we have to solve for r. So if I subtract 6r from both sides and add 13 to both sides, we get r is 20. Then to find the measure of the arc, 7 times 20 minus 13 is equal to 140 minus 13, which is 127. In this example, a chord angle, our vertex is in. You don't really need to know the names as much as focus on where that vertex lies. If it's in, remember that's a good thing. So it's going to be the measure of the arc plus the measure of the arc divided by 2. So to find x, I'm going to take 84 plus 130 divided by 2. So that's 214 divided by 2. That's 107. Following the same formula here, the measure of the angle is 110. That's equal to the arc plus the arc divided by 2. Multiply both sides by 2. Then x equals 220 minus 97, or 123. Our next set of examples is the vertex is on the circle. It's an inscribed angle. And in 9.2, we talked about if the vertex is on the circle, the angle measure is half of the arc. So to find the measure of angle MPN, that's going to be 70 divided by 2, or 35. And then to find the measure of arc PO, that's going to be twice 56, or 112. The trick with some of these problems can be to focus on which angle is making which arc. So at times a highlighter will be helpful. I did post the PDF online so that you can print that out if that helps you. CF is formed by angle CDF. So the measure of the angle times 2 is the measure of the arc. To find the measure of angle FAC, I have to use the information that I just solved. That's going to be 80. This is now what I'm looking for. And I also need this arc. So I'm going to need those two arcs. It's in, the vertex is in the circle. So the measure of the angle is arc plus arc divided by 2. If the vertex of the angle is on the circle, then the measure of the angle is half of the arc that it forms. So I know all the way around the circle is 360. I know arc BD is 154, which makes BCD 206. And then angle ABD is half of that, so that's 103. To find the measure of arc PM, I'm going to need to double the measure of angle PMQ. Here, the vertex is outside of the circle, so I'm going to need to take the big arc minus the little arc, so I don't get a negative number. If you do it backwards, just take the absolute value, and then divide by 2. So there's my vertex outside. I'm going to take 179 minus 71. Remember, if something is negative, to say something is out, like in baseball, if you're out, that's a negative. So I'm going to subtract those two. So that gives me 108 divided by 2, which is 54. Looking at another example, here we're given the angle measure is 68. And we have to find the measure of arc XZ. That's the minor arc. So I'm going to take 224 minus the minor arc divided by 2 equals 68. To solve for A, I'm going to multiply both sides by 2. I'm going to add A to both sides so that it's positive. And then 224 minus 136 is 88. Again, our vertex is out, so it's going to be arc minus arc divided by 2. So the major arc, x, z, y, is 360 minus 106. So 254 minus 106 is 148. So 148 divided by 2 is 74. Here we're looking for arc JM. Multiply both sides by 2. Add 111 to that. Here again, the vertex is on the outside. Arc minus arc divided by 2. So the angle 2x is equal to 9x minus 1 minus 94 divided by 2. Five goes into 9 once. We have 4 left over. X is 19. We have to find the measure of this arc right here. So 23 degrees is equal to 68 minus arc SU divided by 2. So 46 equals 68 minus arc SU. Arc SU then is 68 minus 46, which is 22 degrees. There's one more example that I'd like to go over with you. If you have an inscribed quadrilateral, so any quadrilateral that's inscribed in a circle, the opposite angles are supplementary. So that means I can take 21x minus 8 plus 23x plus 12, and if they're supplements, they add up to 180. So 21x combined with 23x gives me 44x. 12 minus 8 is 4, and that's equal to 180. If I divide everything right now by 4, and then subtract the 1, I get x equals 4. Now I have to go back to the problem itself to figure out what they wanted me to solve for. Find the measure of D and B. So 21 times 4 is 84 minus 8 is 76. And then 180 minus that is 104.